In this video, I want to have a look at solving non-monic quadratic equations. So that's where our squared term has a number in front of it that's not a 1. So for example, a 2x squared or a 9k squared. Now, solving non-monics is one step more challenging than solving monic quadratics because it's a little bit more complicated. But let's go through the process. So the first thing we want to do in this one is factorize this left-hand side, and we're going to use the PSF method. So product, sum, factors. Now remember with non-monics that the product isn't just the constant term on the end. We have to multiply the coefficient of the squared term by that constant. So in this case it's our 2 times 2 would give us our 4. The sum is still just the coefficient of our x term, so that's going to be a 5 in this case. So for this one our factors would be 1 and 4. Now remember with non-monics that's now going to become how we split that middle term up. So we're going to split the 5x into a 1x and a 4x. All right, now that we've split that middle term up, we can factorize by grouping. So if we have a look at this first two terms, we want to pull out any common factors. So our common factors here would be an x. So if we divide 2x squared by x, we'll be left with 2x. And if we divide an x by an x, we'll just be left with 1. Now in this second chunk, we're going to put out a 2 as a common factor, and we'll have a 2x plus 1. When you get to this stage, if these two brackets aren't the same, then something's probably gone wrong. All right, now if we have a look at it, we can pull out this whole 2x plus 1, that whole bracket, as our new common factor. In our next bracket, we're going to be left with our x plus 2. Now that that's fully factorised, we can now separate these two sections, because if we've got them both multiplied together to give 0, at least one of them has to be equal to 0. So we're either going to have 2x plus 1 is equal to 0 or x plus 2 is equal to 0. So solving both of those, we have 2x equals minus 1, so x is equal to minus a half, or x is equal to minus 2. All right, so that's our first example. If we have a look at our second one, it looks a little bit different because we don't have everything on one side of the equal sign and then an equal to 0. So the first thing we're going to do is rearrange it so that we do have it looking like that. So I'm going to minus that 30k from both sides, and I'm going to slot that term into the middle so that it's in the right order. So now that we've rearranged it, we're going to go through this same process. So PSF. Now a product would be 9 times 16, which is 144. And our sum is going to be our minus 30. So our factors for this one would be minus 24 and minus 6. So that means we're going to split that middle term into a minus 24k, minus 6k, and we've still got our plus 16 on the end. And now we can factorise by grouping. So in this first one, I'm going to pull out a 3k as my common factor, and I'd be left with a 3k minus 8. In this second chunk, I'm going to pull out a negative as my common factor, and 6 and 16, the highest common factor they have is just 2. So that'll leave me with a 3k, and because I pulled out a negative, I'm going to have a minus 8 in there. Now again, those two brackets are the same, so we can pull those out as our common factor. And I'd be left with my 3k minus 2. If I now separate those out, I'll have 3k minus 8 is equal to 0, or 3k minus 2 is equal to 0. If I go through and solve both of those, I'd have 3k is equal to 8, or k is equal to 8 over 3. And in this one, I'd have 3k is equal to 2, so k is equal to 2/3. Now don't forget you can always double check that your answers are correct by substituting them back into the original equation and making sure that it makes sense. So that's two examples of solving non-monic quadratic equations.